This is my economic evaluation model to simplify the study in the journal called Addiction in this week's course readings, this week's required readings, where they're evaluating the potential cost effectiveness of injection sites, supervised injection sites where you could safely inject heroin or other drugs in Ottawa and Vancouver. As usual, we just configure our economic evaluation as a standard cost effectiveness model. Remember, there's sort of other types of economic evaluation, like a partial economic evaluation, cost minimization analysis. But the main type is where you have cost and effects. That's a full economic evaluation. So we're doing a complete economic evaluation where we include both the costs and the effects. So the way we're doing cost effectiveness analysis is sort of synonymous with economic evaluation. The costs are in dollar terms as usual. The effectiveness is in quality adjusted life years as usual. How do you know what the qualities are? Well, you could get them from a survey, you could do your own survey, have an existing survey, and then put them into the model, or just use articles or evidence that's already out there. Like in this case, we're going to talk about risk of injection drugs. Well, the prevalence of injection drug users in the community is something that you could probably get from a government statistics website or local public health authority. We need to code up a lot of variables here in the model. This is going to be an extension of the bivariate sensitivity analysis in my slides on pediatric telemedicine. So the math here is just an expansion of the underlying math from the pediatric telemedicine model. The first variable is people, the number of people who inject drugs in the community. We're going to say it's $2,000 in the base case scenario. So in the deterministic model, where we say exactly how many people and what the risk of needle sharing is, we're going to say there's 2,000 people and then say that the risk of needle sharing is half. So half of people are sharing needles. And in the model of the addiction study, what sharing needles does is it decreases the potential effectiveness of a supervised injection site. So you could build these injection sites and give people a safe place to inject drugs, except if there's a lot of needle sharing, then ultimately the program's not going to be effective in terms of saving lives. The effectiveness of the injection site, we're going to say, is a decreasing function of sharing, so you could see it right there. Effectiveness of an injection site, 10 minus the quantity, 9 times sharing. So the more needle sharing, the less effective our injection sites are. The really underlying economics of this model is economies of scale. So what we're going to say is that our result is going to be that it's more cost effective to build 2 injection sites than 1 injection site. So the first injection site, there's a lot of costs that might not carry over into the cost of a second injection site. So the second injection site you build, you already went through a lot of the transaction costs of arranging the different business deals and the transactions, identifying the construction company who's going to build the injection site, and you might not need a new manager. You already have a manager for the first injection site, and then maybe they could just have a partner, or maybe they could, if the injection sites are close enough together, you could just have one manager go back and forth between them. So there could be economies of scale from sharing resources and decreased transaction costs. So multiple reasons why a second injection site would cost less at the margin than the first injection site. So we'll say that the cost is different between the first and second injection sites that you're building. It costs less the more injection sites you build, but we'll say that effect is always the same. So effect depends on the risk of needle sharing, but effect does not matter whether it's the first injection site or second injection site. We're going to simplify things and just say that there's this underlying effectiveness of 1 injection site, and that effectiveness would apply whether you build 1 or 2. I'm going to start with 0 injection sites here. So $10,000 per quality adjusted life year, that's a status quo intervention. So that's sort of what we're getting for what we're doing now to address the injection drug epidemic. Now the next 2 options are deciding to build 1 injection site or to build 2 injection sites. And then in the addiction article, they go up to 3, 4, 5 injection sites, and I think they ultimately recommend in cities like Ottawa or Toronto, cities of that size and that prevalence of injection drug use, that you would recommend building at least 2 or I think they say 3 injection sites in those cities. So in a sort of hypothetical city here, to simplify it, we're just going to say we're going to either just stick with status quo, or we're going to approve construction of one injection site, or we're going to approve construction of 2 of them. So how the economies of scale go in is you just add the costs together. So one injection site has the cost of the first injection site plus an effect. When you build a second injection site, remember we said the cost functions are different. It costs less for the second injection site for multiple reasons. So we add the costs of the first injection sites together, and then we get 2 times effects. So we're building 2 injection sites, we just get effect plus effect, because we said that effect does not depend on whether it's the first site or the second site, but cost does. So we add up those 2 different cost functions, and then we just say effect plus effect or effect times 2. So you can see we have the model here, and so we're choosing between these 3 options, how many injection sites to build, as functions of the probability of needle sharing in the population. More needle sharing, injection sites less effective, and also the people. So more people, the more injection sites you would recommend. So the cost effectiveness analysis, this is an extension of the earlier ones we did in other slides. So we actually have 3 options here, but they're all undominated. They're all on the supply curve. So you can see the sort of bendy part of the supply curve, but it's still that neon green undominated. So as you spend more from 0 injection site, spend more, build the first injection site, spend even more, build the second injection site, the quality just life years are also increasing. So you're spending more as you scale up the number of injection sites, except you're also getting more effect for that. And you can see that in the base case scenario where we set the number of injection drug users equal to 2,000 and the risk of needle sharing equal to 0.5 or 1/2 or 50%, that 2 injection sites is the most cost-effective option. You can see that ICER of 2 injection sites is $32,727. That's less than 50,000. So it's going to scale up the supply curve all the way from 0 injection sites to 1 injection site to 2 injection sites. And in that base case scenario, with people equal 2,000 and sharing equal 0.5, we'll recommend 2 injection sites because the ICER is less than $50,000, and it has the highest net monetary benefit of those different options if you go back to that table. So it snips off 0 injection sites, snips off 1, and is recommending 2. So 2 injection sites is the most cost-effective option in this base case scenario where there's 2,000 injection drug users and half of them are sharing needles. If you undo that rollback, we could do a sensitivity analysis. And remember from the other slides that a sensitivity analysis is where you look at the different variables and how they influence your recommendations. So now instead of saying there's 2,000 injection drug users in the community, let's look at a range of number of injection drug users from 1 injection drug user to 3,000 people using injection drugs. And sharing, let's go from 0% needle sharing to 100% needle sharing. Okay, now the first thing you notice about this graph is that, the x-axis is a little messed up, so the first thing we'll do is fix that. The reason the x-axis looks like it does in that picture, like a big blur, is because we wrote that there's 100 intervals. You have to do a lot of intervals to get the smooth curve. Put like 1 interval or 2 intervals or even 5 intervals, you're going to see that the curves are bumpy. They're a little bumpy in the addiction article, but you get even bumpier ones if the intervals are low enough. So the number of intervals does matter because it's going to smooth out those cost functions. But then you can see how I just edited the chart. I changed the x-axis to just show 5 labels. So the same thing, just clean up the labels. We had to run a lot of them to get a smooth function, but we don't have to label all of them. So we just had to be more heavy-handed with TreeAge there and sort of make that visual correction. So just set that aesthetic option to just x scale has 5 intervals, and then the y scale we already set it to 5 intervals. So this is a similar graph to what we looked at for pediatric telemedicine. It's inverted from that one because we're saying that the risk of needle sharing decreases the effectiveness. So the y-axis sort of goes in the opposite, does go in the opposite direction of what we had in the pediatric telemedicine case. But the x-axis is still the number of people. So as you're seeing more and more people injecting drugs in the community, you're going to start recommending more injection sites, given that not everyone is sharing needles. I mean, if everyone's sharing needles, if it's like, 98% or 100% of people are sharing needles, you're never going to build injection sites because no matter how many injection sites you build, people are going to still share contaminated needles and inject drugs with contaminated needles, and you're still going to lose quality adjusted life years. But if the risk of needle sharing is lower and there's a lot of injection drug users, you would scale up to 1 and eventually 2 injection sites. how TreeAge makes that graph is it calculates net monetary benefits for all those different points we set. So think of this data here of underlying the graph. Superimpose the graph on this data. What that graph is it's a paint by number for net monetary benefits. So what TreeAge is really doing is it's going through this giant table, selecting the highest net monetary benefit for each combination of risk of needle sharing, number of people injecting drugs. So risk of needle sharing 0, one person injecting drugs, calculates the net monetary benefit, it's $40,000, and then it's going to color that in the appropriate color. So for every point on the graph, TreeAge is calculating a unique net monetary benefit, choosing the best option, and coloring it in there. So that's why you have to have a lot of intervals, because you're going to get those smooth cost functions, but then you do have to change the scale because TreeAge didn't know enough to sort of set the 5 intervals of the scale, even though we said we needed 100 to get that smooth curve.